Hello, my name is Nicholas Borg, and this is question 4 for the Quality Improvement course project. So as you can see here, question 4 asks us to use Excel and derive or come up with an item-by-item sequential sampling plan for which P1 equals 0.04, alpha equals 0.05, P2 equals 0.12, and beta equals 0.05. And it also asks us to note that the single sampling plan for the given data is n equals 40 and c equals 2. Therefore, the item-by-item sequential sampling plan would be truncated or stopped after the inspection of a certain number of units. So before we get into the problem, let's give a little bit of background. In terms of these data points here, P1 is your acceptable defect rate, while P2 is your unacceptable defect rate, right? So what amount of defects is acceptable and unacceptable? Your alpha is your producer's risk, and your beta is your consumer's risk. And N obviously stands for number of samples, and C is your acceptance number in a single sampling plan. So firstly, what is a sequential sampling plan, and specifically an item-by-item sequential sampling plan? A sequential sampling plan is when you take samples, in this case, item by item, so you take samples one by one. Now, if you were to take groups of samples, group by group, that would be called a group sequential sampling plan. However, here we're focusing on item by item. So you're taking samples one by one from a lot, and you're taking these samples up until a certain number, which is what your N represents, until you reach a certain amount of defects or not, okay? So this is what a sequential sampling plan looks like in a visual form, right? So you have what is called your acceptance line and what is called your rejection line. And now you will keep pulling samples, all right? That's what this line represents. You're pulling samples. See your number of items. And you're pulling samples until it either crosses one of these lines. Whether it crosses the accept line, you'll accept the lot. And if it crosses the reject line, you will obviously reject the lot. Now you may think, well, this can go on forever and ever, right? Well, that's where this truncation number comes in, because there you stop and you decide based on the number of defects whether you want to continue on or not. So let's dive into the problem. Here I have the parameters that were given in this problem here, and I also have all of the formulas taken from a source used to teach me about this subject of how to solve the problem. So your goal for this is obviously to create this acceptance line and this rejection line using the data provided. But to create these, we need H1, H2, and S, right? So you may think, okay, let's go solve for H1, H2, and S. But prior to solving for those, we must solve for K, because we need K to solve for S, H1, and H2. Now, a little bit of background. Your K is basically the slope of your decision boundaries, so the slope of this acceptance and rejection line. Your H1 is your acceptance constant, and your H2 is your rejection constant, while S is the general slope of the data itself. Okay? So like I said, the goal is to reach this XA and XR, or XB, depending on where you find your source from. But to get there, we must first start by calculating K. So let's begin. We're going to take it step by step. So K is the log of P2 times 1 minus P1 over P1 times 1 minus P2. So we're going to start by doing P2, right, equals P2 times 1 minus your P1 value. Okay. Next, we're going to do the denominator. So it's going to be P1 times 1 minus your P2 value. And once you have those, we're going to divide them, numerator over denominator, so it equals your numerator over your denominator. And here we get 3.27 repeating. And finally, to get your K value, we're going to do the log of this number that we calculated prior. So our K value is equal to 0.51491, and we can clean up that data a little bit and make it 0.515. Next, we're going to go about calculating our S, or our slope value. So this is the log of 1 minus P1 divided by 1 minus P2 over your K value. So again, we're just going to take this in steps to make sure we get everything correct. So first step, we're going to do the inside of the numerator. We're going to do 1 minus our P1 value divided by 1 minus our P2 value. That's going to give us 1.09 repeating. Next, to finish off the numerator, we're going to take the log of that number. Okay, so here's our numerator. And finally, we're going to divide it by K. So our S is going to equal this number divided by the K value number that we calculated earlier. So here's our slope. And finally, next we're going to want to calculate our H1 and our H2. All right, let's start with H1. So H1 is the log of 1 minus A, or alpha, divided by beta. And all that is divided by, again, the K value that we calculated earlier. So let's start by doing 1 minus alpha over beta. 1 minus our alpha divided by our beta. Now following that, we're going to take the log of that number. Okay, so it gives us 1.278754. And then we're going to divide that by our K value. And it gives us 2.483. All right, next we're going to calculate our H2 value. So again, let's just take our, start at the top and do our 1 minus our beta. We're going to divide that by our alpha. And we're going to get the same thing because our alpha and our beta are the same number. Next, we're going to again take the log of that number. We're going to divide it by K. Now again, these numbers are the same because our alpha and our beta are the same, right? So now we can go ahead and build out our acceptance line or formula and our rejection line formula. Okay, so following here, we have negative H1, which is 2.483, plus our S value, which, let's clean this up a little bit, .0734 times N, right? Let's do the same thing for our rejection line, which is going to be positive H2 plus that same slope times our N. Now, we have our equations, right? So you may be thinking, what do we do next? What is the next step? How do we actually determine how many defects we're going to, either accept or reject at? Well, there comes our truncation plan and our acceptance and failure values. So if we look back here, it says that for our single sampling plan, the given data is N equals 40. Well, according to my research, whenever you are having a sequential sampling plan, right, it is a good rule of thumb that the truncation value for your item by item sequential sampling plan will be 3 times the value of the truncation number for a single sampling plan. So for our corresponding single sampling plan, the truncation value is 40. Now that means that our truncation value for us is going to equal 120, right? Because 40 times 3 is 120. So at 120 samples, you will quit sampling. Now we want to find our acceptance and our failure values, right? Like I said earlier, at what number of defects will we accept or reject said lot? All right, so what we're going to do here is we're going to use these acceptance and rejectance equations to calculate those numbers. So we can do this equals negative 2.483 plus 0.0734 times that truncation value, which is 120. And that's going to give us 6.325. All right, and we can do the same thing for our failure. 2.483 plus 0.0734, right, times that truncation value of 120. And it's going to give us 11.291. Okay? Now your next question may be, well, how do we accept 6.325 or reject 11.291 failures or defects? How do we have point something of a defect? How do we have a partial defect? Well, we don't have a partial defect, right? We can't. I mean, someone can make an argument that you may have a couple dings or scratches on, say, a car on a production line, but those are still defects, right? we're going to label it as a whole defect, not just a partial defect. So for your acceptance, it is very important that you always round. For your acceptance, it's very important that you always round down, right? So we're going to have 6 as our acceptance, and for your failure, it's always important that you round up. So we're going to have 6 and 12 as our acceptance and failure numbers. So if we were to pull samples, doing an item by item sequential sampling from this lot using this data, these would be the acceptance and rejection line equations. And at the truncation value of 120, which again we found by taking the corresponding single sampling plan data of n equals 40 and multiplying it by 3. Again, through my research, I found that a good rule of thumb was to multiply your corresponding single sampling plan truncation number by 3 for your item by item sequential sampling plan. Now once you have that, we can see that while we're pulling samples, once we reach 120, or we either cross 6 or 12, right, defects, you accept or reject the lot. So say we're pulling samples, we get to 120, and we have 6 or less samples. That means we would accept the lot. We would accept that shipment, or we'd accept that manufacturing group, correct? Now say we get to 120 samples, and we have 12 or more defects, right? Then we would reject that lot, we would reject that shipment, or that manufacturing group. So that is my item by item sequential sampling plan for the data given in question 4. Thank you for watching.